Hi guys, in this video we are going to explore the most commonly used technique to prove mathematical statements. We begin with the direct proof. In a direct proof, we start with non-facts, definitions or assumptions and logically move step by step until we reach the conclusion. The statement to be proven is usually of the form if P then Q, or P implies Q, where P is normally referred to as the premises and Q the conclusion. Let's take a problem as an example. Prove that the product of two even integers is even. Okay. Now we'll make use of facts like x is even and y is even. So if x and y are natural numbers which are even, then we know that there exist two natural numbers nm so that s equals to 2 multiplied by n and y equals 2 multiplied by m. So xy equals to 4 multiplied by nm, hence x and y is even. Another widely used method is the proof by contradiction. Here we assume the opposite of what we want to prove, and they show that the assumption leads to an impossibility or a contradiction. And since the contradiction cannot be true, the original statement must be correct. Let's take, for example, prove that the square root of 2 is an irrational number. So we prove by contradiction. So we assume the square root of 2 is a rational number. So root 2 equals m over n. We also assume that m and n are relatively prime. So making m the subject formula, we have m squared equals 2n squared. So this implies that 2 divides m squared, and from fundamental theorem of arithmetic, we know that 2 also divide m. So m is even, and m equals 2 multiplied by x for some natural number x. Substituting that into the equation, we get n squared equals 2x squared also. And so 2 divides n squared, which implies that 2 also divides n. So 2 divides m and 2 divides n, which implies that 2 divides the greatest common divisor of m and n, which is a contradiction since we assume that the greatest common divisor of m and n is 1. Mathematicians also often use proof by induction, especially when dealing with statements about natural numbers. In this method, we first prove the statement for a certain value, which is usually 1, and then show that if this statement holds for an arbitrary natural number k, then it holds for the next number k plus 1. As an example, let's prove that the sum of natural numbers from 1 to n equals n multiplied by n plus 1 divided by 2. So when n equals 1, the statement 1 equals 1 plus 1 over 2 is true. So the statement is true for the base value 1. So let's assume the statement is true when n equals k. So this implies that the sum of natural numbers from 1 to k equals k plus 1 divided by 2. Now adding k plus 1 to both sides of this equation, we get the sum of natural numbers from 1 to k plus 1 equals k plus 1, k plus 2 divided by 2. So we've been able to show that the truth of this statement for n equals k implies the truth of the statement for n equals k plus 1. So this statement is true for all natural numbers. Thanks for watching. Bye.